Okay, this is a video of finding the zeros of a polynomial function. A warm-up, I'll make this a little bit larger. The leading coefficient here, -2 fixed. The degree, 2 plus 3 plus 1 is 6. 0 has a multiplicity of 2. 1 has a multiplicity of 3. And -3 has a multiplicity of 1. If I add those together, 2 plus 3 plus 1 is 6. The y-intercept, plug a 0 in for x, and I get 0. The leading coefficient of negative degree is even. Both ends go downward. And then if I plot the 0, 0, 1, and -3, and then I plugged in -1.5, and I get 21. So -1.5 and 21 is up here somewhere. It's off the grid space. And then halfway between 0 and 1 is 0.5. Plug that in. At this point here, both ends go down. And then multiplicity of 1 for -3, so it crosses like a line. And then coming down here, 0 has a multiplicity of 2, so bounce off the x-axis, go through this point, and 1 has a multiplicity of 3, so this is a little bit concave up and then concave down. Slide 2, you're going to be able to identify the zeros of a polynomial function when suitable factorizations are available in order to graph the function and identify its key features. This problem, what you can put in here is the factorization. F of x equal, so I need to find the factors of -2 that when I add them together, I get -1. So x plus 1 times x minus 2. Leading coefficient is 1. The degree is 2. -1 has a multiplicity of 1, and 2 has a multiplicity of 1. Plug in a 0 for the x-intercept. That's -2. And then halfway between -1 and 2 is 1/2. I get -2.25 right here. So -1 and 2 are the zeros, and the y-intercept is -2. So I get this parabola. So even degree, leading coefficient is positive. So both ends go up here. I get a parabola. Number 4, factoring this here. The factors of -2, they give me a 1 or -2 and +1. So same as the previous slide. Then the leading coefficient is 1. The degree 1 plus 2 is 3. -1 here has a multiplicity of 2 because it's 2 different places here. And then 2 right here has a multiplicity of 1. Plug in a 0 for x to get the y-intercept is -2. Leading coefficient is positive and the degree is odd. So right side goes up and left side goes down. Then I plugged in a 1/2 and got -3.375. So a -1 is a 0 and 2 is a 0. And then the number of turns, maximum number of turns is 2. So since -1 is a multiplicity of 2, it comes up here, bounces off the x-axis, goes through this point that I found. And then 2 has a multiplicity of 1, so it crosses like a line there. This is greatest common factor is x here. So when you divide out of x, x cubed divided by x is x squared. 5x squared divided by x is 5x. Negative 9x divided by x is negative 9. Slide 6 is the difference of square. Square root of x to the 10th is x to the 5th, and square root of 9 is 3. And then put a plus and a minus. Slide 7 is the product of binomials. So we'll find the factors of 20 that when I add them together get a 9 is 4 and 5. So x plus 4 times x plus 5. If I multiply this together, get what I originally started with. X times x, x squared. X times 5 is 5x. Plus 4x is 9x. And then 4 times 5 is 20. Number 8, it says to state the technique and then factor. So this is a difference of square. Square root of 9x squared is 3x. Square root of 25 is 5. And then put a minus and a plus there. Second one is find the common factor and then do the difference of squares. So x is common to both of these. X cubed divided by x is x squared, and then negative 25x divided by x is negative 25. And then I want to factor what's inside the parentheses there. So this is a difference of squares also. So square root of x squared is x, square root of 25 is 5, put a minus and a plus. Number 10 is a product of binomials. I'm going to find the factors of negative 15 that when you add them together you get a 2. That's positive 5 and negative 3. So x plus 5 times x minus 3. And number 11, you want to do this difference of squares twice. Square root of x to the 4th is x squared. Square root of 1 is 1. Put a plus and a minus. And then the difference of squares here is square root of x squared is x, square root of 1 is 1, x minus 1, and x plus 1. And then 12 is the difference of squares. Square root of x to the 12th is x to the 6th, square root of 36 is 6, minus and plus, you're done. Can't factor this anymore. 13, you want to find the factors of 24. That when you add them together, you get a negative 11 is negative 8 and negative 3. So x minus 8 times x minus 3. Slide 14 is a common factor, 7x. 14x squared divided by 7x is 2x. And then 21x divided by 7x is 3. And this is a minus, so I put a minus there. Find a common factor first, and then the product of binomials. So x squared is common to these three terms. X to the 4th divided by x squared is x squared. Negative 5x cubed divided by x squared is negative 5x. And 6x squared divided by x squared is 6. Then I want to factor what's on the inside the parentheses there. So find the factors of 6 that give me a negative 5 is x minus 3 and x minus 2. And then the factors of 25 here, they give you a 10 or 5 and 5. The shortest way to write that is x plus 5 squared. In 17, you want to factor this x squared plus 4x plus 4. The factors of 4 that give you a 4 are 2 and 2. So the shortest way to write that is f of x equal x times x plus 2 squared. The leading coefficient is 1. The degree is 1 plus 2, which is 3. Equate the factors to 0. You get x equals 0 or x equal negative 2. 0 has a multiplicity of 1 and negative 2 has a multiplicity of 2. The y-intercept, plug in a 0, you get 0. The end behavior, leading coefficient positive, the degree is odd. The right side up goes up, left side down. If I plug a negative 1 in for x, I get negative 1. Maximum number of turns, 3 minus 1 is 2. So I plot my zeros, 0 and negative 2. I plotted negative 1, and then this comes up here. Multiplicity of 2 bounces off the x-axis. Multiplicity of 1 looks like a line. And then 18, factoring out the GCF is x squared. You get x minus 1. Leading coefficient is 1. Here, degree is 3. Equate each factor to 0. You get 0. And 1, 0 occurs twice. And 1 occurs once. The y-intercept is 0. The end behavior, positive leading coefficient odd. Right side goes up. Left side goes down. If I plug in a 1/2, I get negative 1.25 right in here. The maximum of the turns is 3 minus 1 or 2. The right side goes up and left side goes down, then connect together the dots there. And 19 is the difference of squares twice. So you have x squared minus 4 and x squared plus 4. And then the difference of squares again, x minus 2 times x plus 2 times x squared plus 4. The leading coefficient is 1. The degree, 1. The degree is 4. So both ends go up. Positive and even. The zeros, 2 has a multiplicity of 1. And negative 2 and if I did x squared plus 4 equals 0, then next step would be x squared equal negative 4, and then x equals plus or minus 2i. So I get 2 complex roots. And then the y-intercept, plug a 0 in. I'm just going to plug it into the original 0 to the 4th minus 16. is negative 16. It's off the grid space. And the zeros are at 2 and negative 2. And both ends go up. And 0, negative 16 is way down here somewhere. And the maximum number of turns halfway between negative 2 and positive 2 we already found is 0. It's negative 16. Maximum number of turns is 4 minus 1, which is 3. So this goes way down here. Goes through 0, negative 16. And then 20, you want to do the GCF and then product of binomials. So the GCF is x, and you get x squared minus 2x minus 3, and then you want to take the factors of this. So factors of negative 3 they give you negative 2 are negative 3 and 1. Leading coefficient here is 1. Degree is 3. The ends look like that. And then 0. Zero is a multiplicity of 1. Or, yeah, and 3 has a multiplicity of 1. And the last 0 is negative 1. And then the y-intercept, plug a 0 in for x. 0 cubed minus 2 times 0 squared. And minus 3 times 0 is 0. So you're going to plot 0, 3, and negative 1. And then the end behavior, this goes up, this goes down. And if I plug a 1/2 in, whoop, let's do it this way. Yep, try this again. So 1/2 cubed minus 2 1/2 squared, and then 3 times 1/2. So at 1/2, let's make this negative 1/2 here. So you get about 1 there. So up here, and maximum number of turns, 3 minus 1 is 2. So halfway between 0 and 3 is 1.5. So we change this to 1.5 real quick here. And you get negative 5.625 down here. So connecting that all together, something like that. All right, in this slide 21, you should have did on the last activity. Some of you haven't done it yet, so I'll remind you in class.